Hello again. As part of our Brock Talks technical series, Brock's going to talk pair valves. We were, as you can see, pretty deep in the middle of our 2017 GSXR 1000 project, and this was a great time. The pair valves right here, everything's exposed. I wanted to just talk to you a second about what a pair valve is, what it does, and what it means to you and your motorcycle, because we're doing the same thing for our project bike and what it means to us. So just quickly and in layman's terms, as quickly as we can do it so that we can all understand, a pair valve, PAIR, actually stands for Pulsed Secondary Air Injection System. So not exactly a direct acronym. In the old days they called it pulsed air. So that's where the name comes from. And it's part of your motorcycle's exhaust emission control system, which is a combination of quite a few different things. It can all get really technical and a little bit boring. So what I'm going to do is just sort of show you how it works, at least the pair valve part of it, and how it applies to what we're doing here. So let me get started. We'll do that right now. So for this demonstration, we've removed the airbox completely so we can expose the pair valve. This little thing right here is the valve itself, and the valve is connected to a reed valve assembly in the top of the head, which is just some little valves that open and close to help produce a vacuum. This hose connects to the bottom of the airbox, and I'll show you that here in a minute. This electrical connection here, you can see I've got this unplugged. This is what is known as a normally open valve. So this valve is constantly open to allow this hose to draw air into the valve unless the ECU tells it otherwise. So just to show you how this works, I'm going to start the bike and demonstrate the vacuum. The bike change pitch, but it doesn't actually affect the running of the motorcycle. And you can see the vacuum is closed, or stopped, so there's no more vacuum. And that vacuum happens at low throttle openings. As you run the bike, the vacuum will naturally stop. You can see the valve's not open. The ECU is not controlling this, and I'm going to show you something real quick that's sort of cool. Pretty cool, right? The ECU was not controlling this valve. It lost vacuum on its own. So what we know is the bike is drawing vacuum through the exhaust system, mainly at low to mid RPMs, and then it stops it on its own as the bike revs higher. We didn't have a 2017 GSXR 1000 head lying around, but we did have a Generation 1 Busa, which had the same kind of situation. It just had a slightly different switching valve. So how did it make vacuum? The exhaust is flowing out through here. There's a hole in the exhaust port, which that's how the air from the airbox gets into the exhaust port, is drawn in. As the exhaust flows out, air goes in. Pretty simple stuff. On the GSXR, this port simply goes up through the head, through here, into the little reed valve assembly. The number one question we receive in regard to the pair valve is, if I block it, can I make more power? No. We're injecting air into the exhaust, or the exhaust is drawing air in from the airbox as part of the emission system. Blocking it is not going to make any additional power. There's no power to be made. All we're doing is adding air into the exhaust to help burn any residual fuel that was unburned from the combustion process. So there's no power to be made there. And also adding the additional fuel, if you have a stock OEM exhaust system, you've got a catalytic converter in there. Some of the aftermarkets do also now. And that additional oxygen being injected into the system can help the catalytic converter heat up and make it work more efficiently to help the environment. So you're not putting out any additional or more emissions than you should. So from a power standpoint, there's simply none to be made there. So why would you block it? Well, if you have an aftermarket exhaust and you're racing with it, you don't really need to be injecting air in there. It is going to create some additional heat that aftermarket exhausts don't need. And the other advantage you have is you can remove the pair valve assembly. You can put block-off plates on there if you like, and you can save that weight for racing. Well, there's another option that we give you that's very simple. With our exhaust systems, we usually give you something for that, which I'll show you here right now. With our Brock's Performance exhaust, we usually include a very simple cap that will fit over top of that nipple, and then you take the hose we were just using and slip it over top, and all we're trying to do is block off that hose. In the old days, we had pair valve caps for the Hayabusas. We've even used marbles. Just stuff a marble in there. How you block that hose doesn't matter so long as you get it blocked. Now, there are some people that when you leave the hose unblocked, you're injecting air into your exhaust, and with an aftermarket exhaust that doesn't have a cat in it or a large muffler like this, it's going to cause decel pop when you let off the gas. Pop, 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 pop. Raises all kinds of hell. It's happening in the stock exhaust. You just can't hear it. With an aftermarket exhaust, it's going to pop, boom, crack every time you get off the gas. We have customers that absolutely love that. If you want to do that, just don't use the cap. You can do that. Now, one thing that we might want to add, if you do block the cap or you block the pair, and you keep your OEM exhaust with the cat, but you go with, let's say, a slip-on exhaust, well, now you are adding, you're adding a richer fuel mixture to the cat, which could cause it to block up. Not only is that not good for the environment, but if you block up the cat over time, your bike could start running poorly. So that's something that that's something you have to decide for yourself, because nobody wants their bike to run poorly. So keep that in mind if you block the cat or the pair valve, if you do have an OEM exhaust with the cat still in it. One last thing I want to point out, I want to show you something with the newfound flash technology that we have when it comes to the definition of disable that some might not realize. So let me show you that. This is what I was talking about when it comes to flashing our own ECUs that some may not actually understand. So we're in here, here's pair valve. It says pair valve, disable, enable. Well, you could take for granted that that means we're going to disable or enable the pair valve. If you click disable and assume that it's disabling the pair valve, well, that means that it's actually disabling the FI code that you would receive if you unplug the pair valve. It's not blocking the pair valve. So what does that mean when it comes to tuning your bike? Let me show you. So what does it mean if I think my pair valve is blocked, but it's not blocked, and I try to tune my motorcycle? Well, as we showed you with the vacuum in through this line, it's going to draw air into the exhaust system at low to mid RPMs. And it doesn't matter whether you're tuning with the bike's O2 sensor, a wideband sensor, a sniffer on the dyno. It's going to pollute, I shouldn't say pollute, dilute the charge coming out of the exhaust with air and give you a false reading. So you can tune away, but the reading's going to be false, and it's going to give you an overly rich mixture in your map. So whether you've got an auto tune or you're tuning with, your power commander on the dyno, or even with an active tune through your ECU, the readings are going to be false. So you have to make sure that your pair valve is blocked when you're tuning your motorcycle, or it's going to be incorrect. So hope this straightens up some misconceptions. Hope it clears some things up. Hope you learned something. Until next time, I'm Brock from Brock's Performance.